Okay, so at this point, you should have your paper ready. Remember, you can find it in Canvas under Modules, Unit 1. If you didn't print it out, you can have a piece of paper and you're just going to write as I write. I also have colored markers so that I can underline key things, so when you go back you can really see where I'm coming from on the notes. You don't have to, it's just an option. So this is notes for 1.1, simplifying expressions by combining like terms. So the first part we have are the key terms and the definitions and their examples. So we have variable, coefficient, exponent, and expression. So variable is a letter that represents an unknown number. A letter that represents an unknown number. And my example, I like to give a couple of them, so I have examples. So X, A, N. So a letter that represents an unknown number. Coefficient is the number in front of a variable or a term. So the number in front of a variable or term. So my examples, if I have 6a and 2xy, the number in front of that variable, the letter, is a. The number in front of that xy is 2. So in this first problem, the coefficient of 6a is 6. The coefficient of 2xy is 2. Okay, exponent is a number that tells us how many times a number or a variable is multiplied by itself. Yes, this is a longer definition. So a number that tells how many times a number or variable is multiplied by itself. So my examples. So 3 squared. So that little 2 really means the exponent is 2. So it means I need to multiply that 3 2 times. So it really means it's 3 times 3. Another example would be 4 to the 3rd power, or 4 cubed. And that just means 4 times 4 times 4. Expression. This is another long one. A mathematical phrase that may contain variables, constants, and or operations. So here we go. A math, I'll even just simplify it. A math phrase that may contain variables, So here we're talking about the variables from right here. So the letters, constants, which are actually just numbers, and or operations. Now, for operations here, we're not talking about I'm going to the doctor and I'm having an operation. We're talking about mathematical operations, which are just add, subtract, multiply, and divide. So it might have letters, numbers, and operations in it. So my examples would be 2x plus 3. So you can see I have a coefficient, I have a variable, I have an operation, and I have a constant. Now, expressions do not have equal signs. Okay, those are equations, and you can hear the word equal, but this isn't an equation. There's no equal sign. I'll give one more example, and it doesn't always have to be x. It could be anything. So 3f minus 2. 3f minus 2. So, well, that's a little late, but it's fine. So I still have a coefficient, I have a variable, I have an operation, and a constant. 3f minus 2, it's still an expression, not an equation. So now I'm going to move down to the bottom half of my page. I kind of like to move as I go because I figure with a video you can stop and pause me at any point, go through the material and write it in as you need to. You can take your own time with this. So another word for combining like terms, it's just matching and adding. You know, once again, we like to sound a little fancier, especially with expression, exponent, coefficient. Combining like terms just means matching and adding. So the first step, so these are steps. I would probably put the word step. So we know that it's step 1, 2, 3. So we're going to determine which parts of the expression have matching variables. So when we're looking for matching, they must, and I might even underline must because it's that important, they must have the same variable and exponent. And I'm going to run out of room with my writing. I'll just squeeze it in. They must have the same variable and exponent. Step 2, add the coefficients. And keep the variable. Step 3, repeat. Feel like this is on a bottle of shampoo. Apply, rinse, repeat. Repeat until you cannot anymore. Okay, so step 1, determine which parts of the expression have matching variables. They must have the same variable and exponent. Step 2, add the coefficients, keep the variable. Step 3, repeat until you cannot anymore. Okay, next page. So now we are trying the problems. I'm going to zoom in just a little bit more. Oh, I can't. So we're going to Make do with what we have. So my first question is for number 1, what can I match together? So I have 7m plus 5m minus 6. So what can I match together? Well, I have a 7m and a plus 5m. Now, that addition sign sticks with the 5m. So I have 7m plus 5m. And basically, it's just like saying 7 apples plus 5 apples. I'm just adding them together. So 7 plus 5 is 12. And I need to go back and it says keep the variable. That was step 2, right? Keep the variable. That variable is m. M has to stay with it. Okay. I don't have anything else that I can combine. I have a cute little minus 6 left all by itself. So when I write my answer, I can't forget it because it's still part of the expression. So I have 12m, and that negative sticks with the 6, so 12m minus 6. That is my answer. So I'm going to circle it in black. That's my answer, 12m minus 6. Let's look at the second expression. 7p minus 9p plus 5. So once again, I need to go to step 1. Step 1 says, what part has a matching variable? Well, right here, they're both p. They don't have any exponent with them, so I can combine them. And so once again, 7p is right here. The negative stays with the 9. So I have 7p minus 9p. Once again, I'm looking at 7 take away 9. And I know if I start my number line and I'm here at 7, if I'm subtracting 9, I'm going to the left. Remember, we subtract going to the left, we add going to the right. So 7p minus 9p gives me a negative 2. Don't forget that variable. That's super important. So I have negative 2p. Well, what's left? Just that extra plus 5. I can't combine it with anything. So my answer is going to be negative 2p plus 5. That is my answer. I can move on. I want to make sure that I'm using all parts of the expression. All parts of the expression. Let's look at the next expression. I have 4x squared plus 3x minus 2x. Okay, there are a lot of x's in this equation, but I need to also check the exponents. So here I have a 4x squared. That 2, remember, means squared. Do I have any other x squared in this equation? No. So 4x squared gets to be by itself. I don't have anything that I can combine with that. So it stays by itself. When I'm looking at my x's, well, let's see. I have a plus 3x and a minus 2x. So I'm just going to write them down here because I like to combine down below so I can see what I'm doing. And my timer just went off, so I know my bread is ready. But if I have a positive 3x and I take away 2x, I'm left with 1x. The rule for math is if there's a 1 in front of a variable, don't put it. So let me make sure I say that again. If there is a 1 in front of the variable, you don't put it. You just leave just the variable by itself. So 3x minus 2x is just x. So now I'm going to write my answer. So I was left with that x And I can't forget my 4x squared, so I have to put that in the equation as well. Now, as mathematicians, we normally like to put things in order from the highest exponent down to the lowest. So if I was being a real stickler on this, I'd put that 4x squared because that's my highest exponent, plus x, and that will be my final answer. Okay, number 4, let's look at that expression. I have 5x plus 7y minus x plus 2y plus 3x. Oh, we got a lot in there. Okay, so I see x's and y's. So I'm going to combine all my x's. I'm just going to circle them. I have a 5x. I have a minus x. And I have a plus 3x. So I'm going to write them out. 5x minus x plus 3x. Now remember, there's an invisible 1 in front of that x. Just like over here when I said if there's a 1 in front of it, we don't put it. Guess what? We don't put it, so that's why it's not there. So really, if I'm doing the math, I'm going to do 5 minus 1 plus 3. So 5 minus 1 is going to give me 4. 4 plus 3 is going to give me 7. Keep that variable, super important, so I get 7x. And when I come back here and I have 7y and 2y, I can combine those. So that's a positive 7y and a positive 2y. And I know a positive and a positive like that, that's just going to be easy to add across. So 7 plus 2 will give me 9. Don't forget that variable. And I'm left with 7x plus 9y. I try to do something a little different when I'm trying to cover the information for you so that it makes it a little bit more clear on what I'm circling, figuring out which colors really stand out and look separate. So bear with me, it's my first time making a video. Number 5, we have 26a plus 2b minus 4a plus 10b. Once again, I'm seeing A's and B's, not seeing anything else. So I'm going to circle my A's. Remember how important it is to circle that sign in front of it. If there isn't a sign in front of it like this at the beginning of the expression, we know that it's positive. But throughout the expression, I want to make sure that I circle that in front because that's important that it's negative as opposed to a positive. So when I'm doing the math, I do it correctly because I've circled that negative part. So when I'm writing, I know it's, oh, hi, first mistake, 26a minus 4a. So now I know it's definitely subtracting. So if I do 26 take away 4, I get 22. The a has to stay there. Variable doesn't go anywhere. And now I'm looking at my b's. So I have 2b, a positive 2b, and a positive 10b. So I just write it out. So if I'm adding a positive 2 plus 10, just going to count up and I get 2 plus 10 gives me 12. Can't forget the b, can't forget the variable. So my answer is going to be 22a plus 12b. Circle it, and we can move on. For my next one, I'm looking and it says not sure what's going on, technical difficulties. Okay, just so you know, we had some technical difficulties. My computer decided it wanted to just log off. Sorry about that. So we're on to this next problem. When I'm looking at number 6, it's an expression, negative 15n squared plus 4n plus 2n. So I don't have any other variable besides n, but I do have n squared and just n. So for this one, let me try to use it round this time. I'm going to see I have an n squared and an n squared, which means I can add the n squares together. So I have a negative 15n squared plus 4n squared. So negative 15n squared plus 4n squared. Really, I'm looking at negative 15 plus 4. So if I'm at negative 15, if I needed to, I could draw it on the number line. I'm going this way because I'm adding. Adding goes to the right. So I'm going to count 1, 2, 3, 4, negative 14, negative 13, negative 12, negative 11. Keep the variable and the exponent. Going with what's left, I just have a cute 2n all by itself, so I don't have to combine it with anything. So I just get to bring it down to the answer. So my answer is negative 11 squared plus 2n. So far, so good. Next one. Negative 4a squared b plus 7 plus 10a squared b. Looking at this expression, I need to see, do I have something exactly alike? So here I see a squared b, I see a squared b. So I have both variables, a and b, and a is to the second power. Over here, a is to the second power. So I can combine those two. So I'm going to circle them. Negative 4a squared b plus 10a squared b. Don't let the fact that this has multiple variables scare you. Don't. Just really look at it like this. Negative 4 plus 10. Okay, let's make it manageable. Negative 4 plus 10. Well, that's going to give me a positive 6. So I just write down the answer, 6. Now, what was important in step 2? Keep the variable or variables. So it's the same thing that we did right here. All I do is write a squared b. Not intimidating. I just had to look at negative 4 plus 10 and then write that piece right below it. Now, we have this plus 7 piece. It can't be combined with anything, so it can just be brought down. So my answer is going to be 6a squared b plus 7. 6a squared b plus 7. Looking at the next one. 4x squared minus 7 plus 2x minus 3x squared plus 8x minus 6. Ooh, we're starting to get into lengthy ones now, aren't we? No problem. We can do this. Okay, so the first thing I'm going to do is I'm going to look for things that I have in common. I have an x squared and an x squared. So of course, I'm going to combine them. Because all about today is just combining like terms. So I have a 4x squared minus 3x squared, which is really, we're doing just the math with the numbers, the coefficients first. What's 4 minus 3? Well, it's 1. Do we write the 1? No, because it would just be a number in front of a variable. So what's left? Just the x squared. So 4 minus 3 is 1, but we don't write the 1 if it's in front of a variable. Doesn't matter what power it's 2, we don't write the 1 in front of a variable. So we're left with x squared. Now I have a positive 2x and a positive 8x. So I'm just going to add a positive 2 and a positive 8. So it's 2 plus 8, 10. Don't forget to keep the variable. Very important piece to that. Last, I actually have 2 constants that I can put together. So I have a negative 7 and a negative 6. So I'm going to write negative 7 minus 6. So once again, think about that number line. If I'm here at negative 7 and I'm subtracting, it means I'm going this way. 6 more. So that's going to give me a negative 13. So if I write everything out, I'm just writing these 3 answers together. X squared plus 10x, because it's a positive, minus 13. And that's my answer. X squared plus 10x minus 13. Okay, we're done with page 2. Last page, here we go. Last page. Only 2 problems. We can do this. Hands down, right? So now we're going to look at how this applies with geometry, because a lot of algebra you're going to see in your further classes. So this is where we're kind of showing you that it does build, and you will see it in geometry, or how it can relate to geometry. So we're going to talk. Number 9, calculate the perimeter of the figure. Give your answer as a simplified expression. Ooh, okay. So first things first, we need to remember what perimeter is, which means just going around. So it's adding the length of all 3 sides. Well, of all sides. We'll just say of all sides, and then it can be any shape. It doesn't have to be just the triangles. So I need to make sure I'm adding this side plus this side and this side. So 2x plus 1. I'm going to put a check mark next to it just so I know I've used it. Plus 3x plus x. Now I know that I've definitely used all 3 sides. So looks like I've got 2x plus 1 plus 3x plus x. Well, I have a whole bunch of x's I can combine. I have a 2x plus 3x and a plus an x. Remember, this really means plus 1x. We just don't put that 1 in front of it. So 2x plus 3x plus 1x. So 2 plus 3 plus 1 is what we're really looking at, and then we're going to add the variable. So 2 plus 3 is 5, plus 1 is 6. So our answer is 6. Add the variable of x. I can't do anything with that 1. So the 1 just comes down and joins it. So my answer is going to be 6x plus 1. Okay, the next one that we have, once again, it's calculate the perimeter of the figure. Give your answer as a simplified expression. So I'm going to do the same thing I did on number 9. I'm going to go through it, and I'm going to make sure I add up all the sides. So I have a 17 minus a. And my computer really didn't like me and did it again. Okay, sorry for that. Hopefully you just see a pause on your screen. 17 minus a plus 5a minus 1 plus 4ab. Now, I have a's, but over here is the tricky one. It's ab. Okay, I can only combine an ab with an ab, and there are no other ABs, so I'm not going to be able to combine it with anything. I will be able to combine some other stuff though, because I have a 17, I have a minus 1. Those are constants that I can combine. So I have a negative, well, sorry, I have a positive 17. There's that negative 1. So 17 minus 1. 17 take away 1 is 16. There's no variable, so I don't have to worry about adding that variable. Then I'm going to look here. I have a negative a plus 5a. Remember, no number in front of it, so it really means there's a 1 there. So we're really saying negative 1 plus 5 if I'm just looking at the coefficients. A negative 1 plus 5 gives me a positive 4. Don't forget the variable. And as we said before, this plus 4ab isn't going anywhere. So we can just bring it down. As mathematicians, we like to see the letters before, well, the letters before the numbers. Let me rephrase that. We like to see the variables before the constant. So just the number that's by itself, that needs to be typically near the end. As mathematicians, we just do that. So 4a plus 4ab plus 16. Now, if you had told me 16 plus 4a plus 4ab, you have the right answer. Or if you had said 4ab plus 4a plus 16, you would have had the right answer. It's just, once again, we like to leave that constant, the number that's just by itself at the end. Okay, well, that wraps up everything. You need to now go and take your formative. If you have any questions regarding this, please don't hesitate to contact me. You know my office hours, but you can also just shoot me an email and we can find a time that's best for you so that I can help you with the material. So with that being said, I will see you later.